This is a demonstration of using the IBM Application Performance Management Live Demo tool. You can find the IBM Application Performance Management Live Demo at the URL shown on the screen.
This video demonstration contains the scenarios shown on the screen at the timestamp shown on the screen. If you want to fast forward to a given scenario, simply fast forward to the recording to the timestamp. Let's get started. Open up a browser to the URL shown on the prior screen. In my case, it's the home page of this Firefox browser. Note the guided demo steps outlined on the right. We will use these as a guide for our demonstration. I'm going to minimize the guide during the demonstration to give us more real estate to show application performance management. However, feel free to use this as a guide when you run this on your own. This guided demonstration features a live environment with sample data from several applications managed across Linux, Windows, and Unix servers. The sample data is derived from web applications in the cloud, including IBM Worklite on WebSphere Application Server with MySQL database on the back end. Follow the scenarios provided in the guided demonstration or explore the system yourself. At any time while viewing dashboards, you can take a tour by clicking the Learn More icon in the top right corner of the application dashboard banner and selecting Take a Dashboard Tour. If you get logged out due to inactivity, you can re-log in with the user ID guest and the password of guest. Our first scenario is View Application Status and End User Response Time. How can I get started with monitoring my web application and get results in less than 15 minutes? Step 1. Click on All My Applications. Look at the alert icons and colored lines in the summary box title bars to identify applications with a critical or warning status. Step 2. Compress the display on the panel by clearing the Show Details checkbox. Toggle the Show Details checkbox several times to observe the impact. Step 3. Filter the summary boxes that are displayed by clearing the checkbox by each status icon. For example, clear the green checkbox to filter out all applications with a green status. Step 4. To view the details about a particular application and various transactions over time, select the Portfolio Management application on the left. To get some more real estate, let's collapse the All My Applications list of applications on the left. Click the Actions menu at the top right, select Launch to Reports, and click on the Application Performance and Usage Report. A new window with the report is displayed. This report presents the performance availability and devices details that are associated with a specific application. You can understand how the application has been performing overall, and for each type of transaction, the load it was dealing with in terms of transaction count and data volume. You can see the successes and errors by transaction and device, and understand who has been connecting to your application by device type, brand, operating system, and browser. Close the report view and return to the Portfolio Management application. Step 5. Click on the Request and Response Time chart to open the End User Transactions page. Observe that we have a small but consistent percentage of slow transactions. There are two patterns in the slowdowns. In the Worst by User Top 5 chart, notice that only a portion of users, Fred and Eve, have slowdown. And in the Worst by Device Top 5 chart, notice that only device type iOS indicates a slowdown. Click on the iOS row in the Worst by Device Top 5 chart. Step 6. In the Device Sessions Top 10 table, notice the transactions are sorted ascending to their percentage failed and percentage slow response. Observe that for all the session, their response is 100% slow for iOS devices. This is contributing to a bad user experience for the iOS users. The IT operator or developer can click a specific transaction instance to investigate the exact root cause of the problem. In this scenario, you learned how to monitor application and transaction availability and response times that your end users are experiencing. Our next scenario is titled Availability Monitoring. How can a line of business owner or IT operator detect and isolate a problem to a specific geography using synthetic playback for website monitoring? Step 1. Click on All My Applications. Identify the website monitoring application which has a warning status. Click the Website Monitoring Application title bar. Step 2. The Status Overview tab shows Availability Over Time and Event Severity Summary. The availability chart shows some periodic slowdowns. Click on the availability chart to investigate further. Step 3. A new page is displayed that shows the transaction and location lists. Here you can see the transaction status with the response times and which geographic regions are running slow. Notice the payment.js transaction has a high percentage of slowdowns. Click on the payment.js in the transaction list. Step 4. The Transaction Details page displays the details of the transaction including availability over time, response time, playback locations, and subtransactions. And notice that payment.js is playing back at both Dallas and San Jose, but the instance running at Dallas is experiencing slowdown. Click on the Dallas location. Step 5. In the pop-up window, click on any instance. In the Transactions Instance Details page that displays, you can see the transaction instances and locations, the error summary, and the transaction breakdown. Step 6. In the Transaction Breakdown table, expand payment.js and the check_out subtransaction to drill down. Observe the click at routine has a response of over 10 seconds, which is causing the slowdown at the Dallas site. Within a few clicks, you were able to learn the response time and transaction availability that your end users are experiencing in various regions. View transaction details. As an app owner, how do I find transactions with slow response time and isolate the problem? Step 1. In the All My Applications dashboard, locate the Portfolio Management application, which has a critical status. Click the Portfolio Management application title bar to display transaction and component details. Step 2. Click on the request and response time chart to display transaction details. In the page that opens, notice in the request and response time chart that the volume of transactions is fluctuating. In the worst by user and worst by device charts, you can see that users Fred and Eve and the iOS devices are experiencing a slowdown. The transactions top 10 table shows metrics from the lowest performing transactions. In the users and sessions chart, click Analyze Users to display more information about the users. Step 3. This page shows user metrics. Expand the users by location entries to see their geographical distribution and to filter the display. Scroll down to the user at selected location top 10 table. Notice that slowdowns are being experienced by users Eve and Fred, that they are both using iOS devices, and they are located in Durham. Click the first Fred entry in the table to see the session details. Step 4. This page shows the session details for the selected user. Scroll down to see the session instances and click on the first session instance to view the transaction topology details for that instance. Step 5. The topology page shows the transaction instance organized into network hops and sub-transaction nodes. Focus on the nodes with the warning status. As you follow the node hops, you can see a 13-second slow response time that originates with the Java bystock application. Scroll down to the Gantt chart and expand the entries in the chart to confirm that the simple trade bystock entry is responsible for the majority of the 13-second response time. The output from the trade out queue, taking 3.006 seconds, is being sent to the application server. The trade application is taking 9 seconds to process. In this scenario, you found the transactions with slow response times and isolated the cause by drilling down to individual transactions, their subtransactions, and component level details. After identifying the transactions, users, and their geography, the app owner hands over the diagnosis to the developer, who finds the exact line of code causing the issue. Monitor IBM middleware stack. How can a middleware specialist isolate a problem in an application's middleware stack that includes MQ, IIB, and data power? Step 1. Click on All My Applications. Identify the portfolio management application which has a critical status. Click on the Portfolio Management title bar. Step 2. On the request and response time chart, notice that some of the user requests are slow. Click the Zoom tool on Aggregate Transaction Topology and find the Trade QM IBM MQ node and the Trade BK IBM Integration Bus node. Hover your mouse over these nodes to learn more about their status and their generated events. Right-click the Trade BK node and select Go to Transaction Summary page to display detailed information about transactions. Step 3. On this page, you can see that Trade BK has 2 service dependencies. Click on Docker MQ and note the pop-up window that the request volumes are fast and steady. Close the pop-up window. Click on twitter.com:80. Hover your mouse over the message request chart and notice that a high volume of requests are failing, and on the response time chart, notice that the response time is consistently high, 3 seconds. This is possibly contributing to the slow user response time. close the pop-up window. Click on TradeFlow_DB2 in the Transactions table to investigate further. Step 4. This page shows the transactions with TradeFlow_DB2. Select an individual transaction from the latest requests table for further investigation. Step 5. Here you can see the transaction topology breakdown. Notice that our solution has the ability to discover external data endpoints that are not directly monitored by performance management. These are the nodes shown without a status. Scroll down and expand the Gantt chart to find out what is causing the slow response. You can see that for this transaction, trade out XMIT is contributing to the slow response of 3 seconds. In this scenario, we explore the transaction tracking information for IBM middleware products, the services they expose, and how to troubleshoot if any problems arise. Identify and diagnose predictive insights anomalies. As a DevOps user, how can I use predictive insights and analytics to detect anomalies and help me avoid application outages? Step 1. Click on All My Applications and ensure all status filters are turned on. Look at the color and icon in the title bars of the application summary boxes on the Status Overview panel to identify applications with a critical or warning status. Step 2. The credit card processing application has a special icon to indicate that a predictive insights anomaly event exists on the application. Click on the credit card processing application and then click on the Events tab. Step 3. The event indicates that the response time metric is higher than the expected value. Step 4. Click on the event and select View Anomaly Analysis to launch in context the Predictive Insights Service Diagnosis view. Step 5. The Predictive Insights Service Diagnosis view is opened in a new window. Investigating anomalous behavior. Learn how anomaly information is presented to help you identify potential service impacting issues. Step 1. An anomaly event was observed for the credit card processing application in the All My Applications view in the Application Performance Management dashboard. Clicking the event and selecting View Anomaly Analysis launches the Predictive Insights Service Diagnosis view. Step 2. Get familiar with the user interface. The graph shows the values for the anomalous WebSphere agent metric response time. The area in red is the time period during which Predictive Insights has identified that the metric is anomalous. Predictive Insights evaluates, by default, each metric every 15 minutes and generates an alarm if the metric is anomalous for 3 out of the last 6 time intervals. These values can be configured as desired in the on-premise solution. These alarms are sent to the APM to notify the user that an anomaly has been detected. As you move the mouse from left to right, you will see the metric time change in 15-minute intervals. The area in red, which indicates the time period for the anomaly, may be shaded in a lighter color to show that the alarms were suppressed and do not need to be investigated yet. If a metric is seen as anomalous for fewer than 3 out of the 6 time intervals, then the alarm is suppressed and is not sent to APM. In this example, the first 2 intervals are shaded in a lighter color, indicating that no alarm was generated. The remaining intervals are darker to indicate that alarms were generated and sent to APM because the metric has been anomalous for greater than 3 out of 6 intervals. The response time metric has been anomalous for several hours. The timestamp for this anomaly in APM will reflect the last evaluation time for that metric. The event information for the alarm is updated with each evaluation interval as long as the metric remains anomalous. The summary in the top left shows the anomalous resource and the actual and expected values at the time of the anomaly. You can use the arrows to update the summary information and the graph with details of each previous time that the metric was anomalous. The info flyover describes what is happening with the KPI, such as gone outside of bounds, has flatlined, or is varying less. The Related Metrics tab at the bottom of the screen shows the relationships with other metrics that Predictive Insights mathematically discovered. Step 3. Check if any related metrics are anomalous. The anomalous column shows if a metric has been anomalous in the last 3 hours. The icon indicates the type of alarm for the anomalous metric. Hover over the header to show a pop-up with details of the period in which all metrics were anomalous. Hover over the icon to show a pop-up with details on the type of alarm. Step 4. View details of the relationships that were automatically discovered by Predictive Insights. The info column gives details of the type of relationship discovered. Predictive Insights identifies metrics that are good predictors of the anomalous metric and metrics that are historically anomalous at the same time. Hover over the info icon for pool hit ratio to see details of the relationships that were automatically discovered by Predictive Insights. Relationship icons in the info flyover describe all relationships to the target metrics. Step 5. Display the related metrics on the graph. The pop-up for the info icon in the previous step shows us that historically, pool hit ratio is anomalous whenever response time is anomalous. Predictive Insights automatically discovers this relationship and presents it to help you diagnose the issue. For further analysis, display the pool hit ratio metric on the graph by clicking the checkbox beside the metric name. The legend colors match the same metric in the graph, the Related Metrics tab, and in the tooltip. Turn on its baseline by selecting the radio button in the baseline column. The blocks written per second metric is another related metric that you can analyze. These related metrics help you diagnose the problem. Step 6. From the analysis, it appears that response time is high because of decreases in the pool hit ratio in the database. By identifying changes to the database server around the time of the start of the anomaly, you can help pinpoint the source of the problem. In this example, Predictive Insights raised the anomaly 4 hours before a static threshold set at 2500 milliseconds would have alerted the problem. In addition, Predictive Insights did not raise anomalies on the spikes that occurred previously. With Predictive Insights, you don't need to configure metrics, set thresholds, perform tuning, or create rules files. Predictive Insights automatically learns the normal operating values of each metric, as well as the relationship that exists between metrics. When a change occurs, Predictive Insights raises an anomaly so you can avoid service impacting outages. Investigate slow or hung requests. As a middleware specialist, how can I investigate slow or hung requests? Step 1. Click on All My Applications. Identify the Portfolio Management application, which has a critical status. Click on the Portfolio Management title bar to display transaction and component details, and then click on the Events tab. Step 3. Identify the slow or hung request event. The event indicates that the requests currently in flight are not completing correctly. Step 4. Click on this event to expand the display, and click the Managed System link to investigate the slow or hung requests. Step 5. The In-Flight Request Summary widget shows more than 0 requests currently in flight that are not completing. The Average Resident Time field shows how long these requests have been running on average. Click on View Requests to investigate the problem. Step 6. The In-Flight Request table shows the slow or hung requests. Select the slowest running request, first row of the table, and click View Stack Trace to investigate that individual request. Step 7. The Request Stack Trace table shows which method and class the request is hanging on, along with the file and line of code where it is occurring. This is the root cause of the hung or slow request. That concludes this demonstration of using the Live Demo system for IBM Application Performance Management.